Hello students of class 7 standard. Today we will discuss the energy third chapter of physics. Okay, welcome back first of all after the summer vacation. So just try to understand the energy and that this energy is very important chapter and energy you will get in each and every classes. Okay, this energy. So basic thing is present in your chapter. So that basic thing I will tell you today. So this is third chapter of physics class 7 standard. Okay, so what actually we have to know first of all before knowing the energy, that is for three things. First of all, the force you have to know. Okay, second one, displacement you have to know, and third one is the work or work done, you can also tell that one, the same thing. Okay, so three things are very important before knowing this energy, because work and energy are very much related to each other, interrelated to each other. Force and displacement, this is a combined package to give the work, and from work you can get the energy. Okay, so these four, energy, force, displacement, one, work, these all four terms are related to each other. How can you relate them? First of all, we all know that actually work is actually what work, if you write down work, is equal to force into displacement. You have to simply write this one, that force into displacement is the definition of work. Okay, or you can also write down F into S or F into D, you can also write small d, or small s you can also write here. So these two terms, what is the meaning of this? This is a mathematical expression here. Now come to the physics, the actual concept of the force, actual concept of work. What is actually this one? If you apply the force on a body and if the displacement will take place, then you have to say that some amount of work we have completed. Some example I am just telling you. Suppose a body, any mass maybe you have taken. Okay, suppose a body having mass m is kept somewhere. Now if you have give some amount of force on the body, maybe F amount of force you have applied on the body, and maybe the body has shifted this amount of distance or some displacement may be taken place here. This is the amount of displacement taken place here. So in this particular case you have to write definitely that some amount of work we have done. What amount of work we have done? This amount of work we have completed here. Okay, so in basic sense, work means what? Force should be there. You have to apply the force on the body. Definitely D should be there. That means the displacement should also be there. If any one of these two will be zero, then the work will certainly be zero. Suppose you write down that D is equal to 0, that means the displacement is 0. Can you write down that work will exist? Definitely not. You have to write down that work will also be 0 when D is equal to 0. Meaning is that suppose this body, you have given certain amount of force here to the body of mass m, but this body has not displaced. This body is remaining on the same place. Suppose this is the body here, you have having mass m, so you have applied the force F, but the body has not yet displaced from here. So definitely the displacement of the body will be 0. So in this case what you have to say, that I have not done any work or work has not been done. Okay, so this one you have to definitely tell that when the displacement of the body will be 0. Second case, if F is equal to 0, so definitely work is equal to also 0. Suppose you have not applied any type of force on the body, force application is definitely not 0, so certainly the body will not displace from here. So in this case work will also be 0. So if you not apply force, if you not apply the force, then you will definitely not get any work. If you will not get any type of displacement, then also the work will also be 0. So this is the case. Now what I am mainly telling this one, that work and the energy, how they are related to each other. Suppose I am just telling you one thing, that if work has not done, are you able to get any type of energy? Definitely you will get the energy. Thing is that suppose a body is here, a person, maybe here one person is standing like this. This is the person here. So this person have some amount of energy, maybe energy unit is joule, we all know that I will also discuss that one, that maybe the energy of the body is equal to 100 joule. Okay, but if you want to displace, just try to understand that one, this is very important. To just displace the body, 120 joule of energy is required. Okay, 120 joule of energy is required to shift the body from this position to any particular position, or you can also say to give the displacement of the body, 120 joule of energy is required, but this body, this particular person will have only 100 joule of energy. Can you able to get any type of work from here? This is the question. Definitely you won't be able to get any type of work from here, because work will only be possible when displacement will come. So, but this person will have only 100 joule of energy, but this body will require 120 joule of energy to get the displacement. So this person won't be able to give that much of energy because he is having only 100, but 120 is not here. So displacement is 0 here, so work is also 0 here. So in this case work will also be 0. So suppose if you talk about this type of situation, have you noticed one thing, that this energy can be 0 anytime? It is not definitely 0 anytime, because this person may have 100 joule, it could have 20 joule, it could have 10 joule. Some amount of energy definitely be present on a particular body, on a particular person. But is it, if it is sufficient to give the displacement, then that person will give the work or do the work. If it is insufficient, then that person will not be able to do the work. Maybe you understood that one. Again, I am telling the same thing. Try to understand. Energy will be present on a body in every circumstances, in every situations. But if that amount of energy is sufficient to do the work, then you have to say I have, or that person have done the work. If it is insufficient, then it will not do the work. Okay, so energy will be 0, and energy will not be 0, but work can be 0 in a certain situations. Now thing is that in this case you have to learn one more thing, that what is then the definition of work and what is then the definition of the energy. So here work, if you talk about, work means what? That is actually the multiplication. It's a multiplication of force and displacement. Okay, this is a multiplication of force and displacement. Both will come. If any one of this is 0, then the work will be 0. Now what is actually the energy then? Energy, suppose if you talk about, then that is actually definitely capacity of doing work. This is the capacity of doing work. How much work you can do, that will be decided by the energy. Okay, if you have more energy, then you can do more work. If you have less energy, then definitely you have less amount of work. We are the human being, we can definitely do more work than an insect, isn't it? So we have more energy, we can do more work. Any other person, suppose, or any other animal, suppose if you talk about, which is having less energy, then that person or that animal can definitely do the less amount of work. So capacity, how much work we can do, that will be decided by how much energy present in our body. Okay, so these two terms are very much related to each other. Next one is that very important thing, the unit of that one, or units of that one. Two units are there, CGS and SI system, that will be decided by energy or work. Both will be in mathematical form if you talk about, then F into D. Okay, because these two terms are related to each other. Energy will also be defined as this one, and work is also force into displacement. So if you talk about the first SI system, that means MKS system, if you talk about, then in this system, what is actually the unit of energy, or what is actually the unit of work here? So definitely that will be unit of force, that means Newton, and the unit of displacement, that is meter. So you can write down the Newton meter. So that can be written in the form as joule, capital J, or you can write down joule. This is the actual unit of the energy or work. You can also write down in case of SI system or MKS system. Now the definition of 1 joule. what is actually the definition of 1 joule. So from here you can write down, you can see that how much force we have applied to get 1 joule work or 1 joule energy, 1 Newton. How much displacement we are getting here, 1 meter. So to get 1 meter displacement, if we apply 1 Newton force, then our energy is 1 joule. Maybe you understood how much displacement we are about to get, 1 meter. How much force we have applied for that one, 1 Newton. For that reason, if you get the amount of work is equal to 1 joule. Okay, so this is actually the SI unit of that one. In the next video I will tell you the rest, all things, all the units and all. Okay, thank you.